Hello, welcome to the second part of our video on solving polynomials with complex solutions. Of course, in the previous video, we were looking at solving quadratics and cubics, so begs the question, what are we going to look at in this video? Well, we're going to step it up a notch. We are going to look at quartic equations. And of course, quartic equations are equations of this form here. Another way of naming these sort of equations is to call them a polynomial of degree 4. And just like last video, we're going to make our life a bit easier by, for the moment, only specifically looking at quartics which have real coefficients, or entirely real coefficients, I should say. So, if this is the case, what can we say about them? Well, in reality, it's just an extension of what we already know happens with quadratics and cubics. If we have any real roots, you deal with them in the exact same way we used to with at Maths A level, but now we can have complex solutions, and if we have complex solutions, they must appear as part of a conjugate pair, always. However, I guess the one little thing different from cubics is because it's a quartic, it's always going to have 4 roots. Although, of course, those roots could be repeats of each other, but it does mean that, therefore, as we've got an even number of roots, it's possible for them to be made up purely of conjugate pairs, and therefore it's possible to have a quartic with no real roots at all. So there you go, that's something slightly different. But beyond that, it's mostly the same idea, reality, just more of it. Like, for instance, we looked at all the different scenarios you could possibly get for the arrangements of the roots when solving a quadratic and a cubic. And actually, that's what we're going to do now for a quartic as well, except the thing is there's 9 different scenarios that can happen. So let's make things a little more interesting. Instead of me just going straight ahead now and telling you them all, I'd like you to pause the video and have a go at trying to list all of these 9 different scenarios yourself. Saying whether the roots are real or complex, whether they're repeated or not, all that sort of stuff there. So pause the video, have a go at that, and I'll come back in a few seconds and we'll go through it together. Okay, welcome back. Let's go through those 9 different scenarios. Starting off with the easiest one, you have 4 roots. So let's say we have 4 different distinct real roots. Second option, you have one of those roots repeated twice, leaving the other 2 as other distinct real roots. Next one, we start having them repeated even more. So we have one real repeated root repeated 3 times, leaving room for only one more other distinct real root. For the fourth option, we have 2 real repeated roots with each of them repeated twice, i.e. 2 pairs of repeated roots. Number 5, we have 1 real repeated root, but it's repeated 4 times. So that takes up the entire equation's allocation of roots. That's all the scenarios dealing with only real roots. Now we can start involving the complex roots, because we could have 2 distinct real roots and then 1 conjugate pair of complex roots. We could have 1 real repeated root repeated twice, leaving room for a conjugate complex pair. We could have 4 complex roots in 2 conjugate pairs. So they're 4 different complex roots, but they can be arranged into those 2 conjugate pairs. And lastly, we could have 2 complex repeated roots, but because they've got to be in a conjugate pair, it's a repeated conjugate pair. So you've got the same conjugate pair written twice, effectively. Okay, those are the 9 different scenarios you can get when solving a quartic equation. Are you expected to remember all of these off by heart? The answer is no. As you can see, it's a lot of them, and just sitting there rote learning off by heart all of those different scenarios is a bit silly. Instead, you're expected to just know, the implications that those are the different options based on the idea that all complex roots must be in conjugate pairs, and just be aware that those are the only different sort of scenarios you can get. Okay, let's just show a very quick example. In reality, as I said, it's kind of all a bit similar to what we saw with the cubics and quadratics. If you're dealing with real roots, your first approach is just to approach the question just like you would at Maths A level, using algebra division with factors and all that sort of stuff to break the equation down into smaller chunks. However, if you're given complex roots, it's all about dealing with conjugates. So here's our example. We've got a quartic. We're given two roots that are both complex, and we've got to find all the solutions. So first thing to check is the two roots we've been given. Are they conjugates? The answer is no. They're not conjugates, because although we've got a 5i in one and a minus 5i in the other, they don't have the same real parts. So therefore, they are not conjugates of each other. So therefore, actually finding all of the roots of this equation is going to be very easy, because we've got two complex numbers which are roots that are not currently in conjugate pairs. So we've got to find the other complex numbers that go with them to make the conjugate pairs. As we know, all the coefficients are real, so they must be in conjugate pairs. So we do that, and well, boom, there you go. Those are the roots. 5i and its conjugate, which is minus 5i, minus 2 minus 5i, and its conjugate minus 2 plus 5i. We've got four roots. That's all good. That's what we'd expect for a quartic. So everything is good, and we're done. Pretty simple. Nothing really that new beyond what I already said. The last thing to mention is non-real coefficients, polynomials with non-real coefficients. That's quadratics, cubics, or quartics with any of the coefficients not being real. It just needs one of them to be non-real for this to be the case. And, well, it's no longer guaranteed that the complex roots will be in a conjugate pair. The moment that you have any complex numbers in the coefficients, that guarantee goes out the window. Good news is, though, you're not ever really going to have to be solving equations like that. Those sort of equations will only appear potentially, very rarely, in roots of polynomials questions. But it's still being important to be aware of this fact. You can't just start going, oh, wait a minute, I see a complex root. It must be a conjugate to be the other root. If any of the coefficients are not real, that's no longer the case, and you'd have to approach those questions using the methods you find in that particular chapter. Okay, that's all I really have to say on this stuff. Have a go at some questions, and thank you and goodbye.